next concept is instantaneous axis of rotation. After knowing the concept of rolling, we have to say in a rigid body, when it undergoes a combined motion, we should expect some point inside the rigid body or outside the rigid body or in the extended rigid body should remain stationary at the given instant. For instance, you take this rigid body, plate-like structure, this spins and say the center mass move with velocity Vc. If you take any point P, a distance of r from the center of mass, this point will move perpendicular to the line joining P and C with the velocity VPC is equal to r omega. When this velocity of point P with respect to C is added with the velocity C, we are getting the velocity of the point P according to Galilean transformation of velocity. VPC can be written as r omega minus I cap. Vc can be written as Vc I cap. So we are getting Vc minus r omega I cap. If you take this point here at a distance of say r, VQC will be in this direction and Vc will be in this direction. At this point Vc and VPC oppose, but at this point Vc and VQC favor. At some other point you may take. At some other point, at distance of r is a variable. PQ, suppose M. This point may move in this direction with the velocity r omega perpendicular to the radius vector or radial vector, and velocity of C will be in this direction. If you add this two, you are getting the velocity of M in this direction. So if you take any other point, say M, you cannot get zero velocity. If you take the point Q, these two velocities are added to get the velocity of Q. This is not equal to zero. By inspection you can understand. And you can take a point on this line so that there is a possibility of getting zero velocity. This point may lie inside the body or it may lie outside the body, and that point is called instantaneous point of rotation or instantaneous axis of rotation. Instantaneous point of rotation or instantaneous axis of rotation. So this is a point inside or outside, or you can say in the extended rigid body. You can mentally extend the rigid body. So that its velocity is 0 at the given instant. If the body undergoes a combined motion, if the body undergoes a combined motion, omega not equal to 0, that means it is rotating, and Vc is not equal to 0, it is translating therefore. It is having both rotation and translation, means combined motion. Under this condition, there must be a point inside, or that point may be outside or in the extended rigid body. You can extend the rigid body mentally. This is the real stuff. This is the portion in which the real stuff is present. This is the given rigid body or actual rigid body. This is just imaginary region where you can imagine this point P. It may be inside, it may be outside the rigid body, or it may be, this may be inside the extended rigid body. This is extended. It's mentally you have to do it. Extended body. Mentally you have to extend it. But really this body is present in this region. When this velocity of this point P is 0 at the given instant, point P is said to be instant axis of rotation or instant point of rotation. This is the idea, and I will tell you how to use this idea to find that point. Let us take an example. A rolling body on a horizontal surface. This body rolls on the horizontal surface. Say, where is the velocity of the center of mass, and omega is the angular velocity. This point since the velocity of the point of contact that is P is equal to 0, P is called instant axis of rotation or instant point of rotation, and this already you have proved, because Vp is equal to Vpc plus Vc. Vpc is equal to minus r omega. This is Vpc and this is Vc. I cap plus Vc is equal to V I cap. So you are getting V minus r omega. Under this condition, if omega is equal to V by r, you are getting 0. Since this point does not move at this instant, this point P is called instant axis of rotation. Therefore, a rolling body on a horizontal surface for a rolling body on a horizontal surface or inclined surface, and the surface must be fixed. The instant axis of rotation is the point of contact. The point of contact, that is P, is the instant point of rotation or instant axis of rotation. At this instant, this point does not move. At this instant, this point does not move. At another instant, another point will be there. This point P will be go to some other position, rotating through an angle theta. When the body is rotating through an angle theta, this point P goes from this position to this position. This first position is second position. Another point will come to occupy the contacting position. The contacting point for different positions are different. The contacting points at different instants are different. At this instant T1, this is the contacting point. At another instant T2, this is the contacting point. Therefore, always the contacting point of a rolling body on a horizontal surface which is fixed is called instant point of rotation or instant axis of rotation. Let me take another example. Let us take a disk. The disk spins with an angular velocity 2v by r, and the center of the disk, let move in this way. Find instant axis or instant point of rotation. Let us extend the body. We do not know whether the point of instant rotation is lying inside the body or outside the body. Let us first draw a perpendicular to the given velocity. The first step is what? Draw a perpendicular to given velocity. This point velocity is given, or this point velocity is given. Draw a perpendicular and take a point P at a distance of r from the given point. This point P is assumed to be fixed with the extended rigid body. This is called extended rigid body, extension. This is the real stuff. This is extended. This point P, when it spins in this way, this point P must move with respect to O in backward direction with a velocity r omega in backward direction, of course. This magnitude I am writing. direction I have shown. Velocity of this point P, then write Vp is equal to Vpu plus Vu. O may not be the center of mass, may be any other point. But here the center mass velocity is given. Vpo is equal to minus r omega I cap and Vo is equal to V I cap. So you are getting minus r omega plus V I cap. This is not capital R, this is small r. Third, put Vp is equal to 0 as per the principle of instantaneous axis of rotation. That point velocity must be 0 to get simplifying all this. We have V minus r omega is equal to 0. So r is equal to V by omega. If this V is given as V, omega is given as 2V by r. So we are getting r equal to capital R by 2. Capital R is the radius of the disk. Since small r equal to capital R by 2, therefore this point must lie here. Hence the point P, instant axis of rotation, must lie inside the disk. Case 1. If omega is equal to V by r. Let us take another case. In case 2, let us assume that omega is equal to V by r. When omega is equal to V by r, up to this, every step can be considered correct. But here omega can be substituted by not to V by r, this V by r, and ultimately you are getting small r is equal to capital R. You are calculating small r from the given point. Small r is equal to capital R. It means that the location of the instant axis of rotation must be here. It must be the lowest point of the disk. Let us change the case. If the case is changed to omega is equal to V by 2r, say, you can write omega at this position of the procedure. You can write omega is equal to V by 2r to get small r is equal to twice the radius of the disk. So when r you are calculating from this point, and you are getting the twice the radius of the disk, hence the point must be lying outside. Hence the point P must be lying outside the disk. So under 3 different conditions, sometimes the instant axis of rotation or point of rotation is present inside, sometimes just at the periphery, sometimes it is outside. So, instant axis or point of rotation is a point which may lie inside or outside the body or outside the body, or if body is not present in this zone, we can call it extended body, whose velocity is 0 at the given instant. Okay, let's take another example. This is a rod. Spins with angular velocity omega, and the center of the rod let move with velocity v. So the omega is equal to v by say 3L. L is the length of the rod. Question is, find instant axis of rotation. Let us extend the rod. We do not know whether the rod instant axis of rotation is lying inside it or outside the rod. Let us take a point on the perpendicular drawn to this velocity vector at a distance of suppose r. This point P moves with the velocity Vp O with respect to O is equal to r into omega, and bring the velocity of the point O, that's equal to V I cap. The velocity at the point P is given as Vpo plus Vo. Vpo is equal to minus r omega I cap. Vo is equal to V I cap. And put Vp is equal to 0 as per the principle of center of the instantaneous axis of rotation. And you are getting r is equal to V by omega. Since omega we have taken V by 2L, we are getting 2L. R is equal to 2L. So this point P is the instant axis of rotation, must be situated at a distance of r is equal to 2L. If O is the center of the rod, in the previous example, if we change the parameter, suppose omega is equal to V by L, extend the body, draw a perpendicular onto this velocity vector, take a point P on the extended body. Suppose this is O and this distance is R. So this is the velocity of P with respect to O, and the velocity of O, that's equal to V. Condition is that if we assume that this point P is the instant axis of rotation, this point should not move at this instant. So Vp is equal to 0. Vp is equal to Vpo plus Vo is equal to 0. Vpo, this point P moves with respect to O in this direction because it spins in this way. That's equal to minus r omega in backward direction plus velocity of O is V I cap. That's equal to 0. So the instant axis of rotation must be situated below this point on the perpendicular line at a distance of V upon omega. V is equal to V is the velocity of the given point. This is given. And omega is equal to V by L given. So, substitute it, you will get L. When you calculate the R from this point, when you take L below, you will get it outside. This is the outside point. This point is outside point because from O to this point, the distance is L. L is the length of the rod. This distance is L by 2 because this point is the midpoint. Therefore, this point, that is instant axis of rotation, is lying outside the rod. If you take, instead of V by L, if you take 2V by L, let us see. If you take 2V by L, the substitute omega is 2V by L. So, you are getting L by 2. The instant axis of rotation P will be shifted to this point. If you take this 3V by L, instead of omega, you put 3V by L. The instant axis of rotation will be shifted L by 3. L by 3, when you take L by 3 from this point, it will be somewhere here. So, the instant point of rotation will be shifted so that it will lie inside the given rod. So, it depends upon the given point's velocity, so also the angular velocity of the rod. Now, I have to recap from the previous examples to put up a case. Case 1. If the rigid body is given, the plane-like structure, the plate-like structure, it spins in this way, any point velocity is given. It may not be the center of mass or centroid of the body or midpoint of the body. Let it be V. First, draw up a perpendicular to the velocity vector through that point on the plane of the, or along the plane, or in the plane of the body. First, draw a perpendicular to the velocity vector in the plane of the body. Then take a point P, maybe inside or outside. If you take below, then there is a possibility of getting zero velocity, because velocity of the point P is equal to velocity of the point P with respect to O plus velocity of O. If you take below the point O, then this point P will move back with respect to O. And when you bring the velocity of the O, that vector, to this point, then the velocity of the point P can be written by using the Galilean transformation of velocity. Vpo is equal to minus r into omega I cap, and Vo will be equal to V I cap. You are getting V minus r omega I cap. Since you put P is 0, so r will be equal to V upon omega. So, this answer to get the instant axis of rotation at a distance of r from the given point is possible for the condition if the angular velocity of the body and the linear velocity of any point of the body is given. Of any point of the body are given. Any point say P or any point O. This point velocity is given and the angular velocity of the body is given. Then using this procedure followed by these two steps, you can get the location of the instant axis of rotation. It may lie below the point O or it may lie above the point. If you just take the omega in opposite direction, this point velocity is given. Drop a perpendicular onto the velocity vector which passes through the given point to the velocity vector. If you take the point here or if you take the point here, you do not know. You are getting BPO in which direction? This point moves, since it is spinning in this way, this point moves in this direction with the speed r omega, and bring the tail of this vector, velocity vector VO to this point. If you add this two, you are getting the velocity of the point P. If you substitute here, Vp is equal to Vpo plus Vo. Vpo is r omega I cap, Vo is V I cap. Assume, according to the assumption, you follow the Galilean transformation of velocity and get the answer r omega plus V to I cap is the velocity of the point P, and this velocity must be equal to 0 as per the basic definition of the instant axis of rotation. And it will give us r is equal to minus V by omega. The minus sign signifies that with respect to this point, this is below. With respect to this point, this is above. We have taken below, but we got negative answer. Therefore, this point P must be above the point O. When you take above the point O, you can see that this point P is moving back with respect to point O, and point O is moving in this way. When you add these two vectors, that gives you the point P's velocity, which can be equated to 0. Therefore, you can take either below or above the given point whose velocity is given, and you can proceed. If we get negative answer, then alter the assumption. We got negative answer by choosing the below point or choosing the point P below the given point. But you got negative answer. That means this point P must be above. Below, you have chosen below, you got negative. Therefore, this point must be above. This is above, this is below. When you take above, and you will get negative. Suppose you, in this case, you take above. If you take above, you take the instant axis of rotation, a point of rotation above the given point. Here you are getting Vpo, that's equal to r omega. In this way it goes. When you add this velocity with the velocity of the point O, then you are getting this velocity in this direction. The velocity of the point P, the velocity of the point P equal to Vpo plus Vo. Here Vpo will be equal to plus r into omega, and Vo is equal to V into I cap. So the point velocity is equal to V plus r omega I cap. When this point velocity will be equated to 0, you are getting minus sign again. We have taken above, we got negative. What does it mean? This above you have taken, you are getting negative. When you are getting negative, you have to alter the assumption. That means this point P must be below. In this case, when you spin in this direction and this point moves in this direction, P will be below the given point. When it is spinning in this way and this point velocity remains as it is, the instant axis of rotation should be above. However, by choosing a point mathematically on the perpendicular drawn to the velocity vector which passes through the given point, you can mathematically solve the problem. You may get positive answer, you may get negative answer. When you get positive answer, you accept the assumption that is correct. When you get negative answer, just alter the assumption or assumed direction of the position of this point P, just you have to alter. So, this is the idea behind the instant axis of rotation under the case number 1. If the angular velocity of the body is given, the linear velocity of any point of the body is given, you have to first draw the perpendicular to the velocity of the given point which passes through the given point. Then you take a distance r. By inspection you can understand that when it is spinning clockwise and this point is moving towards right, this point must be below. When it is anti-clockwise spin, the point must be above. By inspection we can get the location of the point, and by this formula you can get whether positive or negative. It depends upon the direction of or the position of that point, whether it is below or above. So, the magnitude of the distance of the instant axis of rotation with respect to the given point whose velocity is given is equal to the velocity of the given point upon the angular velocity of the rigid body. Next case I will discuss. If two velocities are given for 2 points of the rigid body, then how to calculate the instant axis of rotation.